Hello there, Mr. Chan here for Algebra 1. We are going to do a 7.4 through 7.7 review. Grab your worksheet review packet and turn to page 309. We are going to do 7-4, Factoring Polynomials. Factoring means to divide or break into pieces, and it's opposite of multiplication. In this second half, we are going to break polynomials, binomials, monomials into small pieces. The first thing they want us to look for are GCFs, or greatest common factors. They have a nice example of that you can look at it on your own right there. I'm going to go ahead and jump to number 29 and find the GCF of each group of monomials. Let's do that. 29, we have 6x squared and 21x. So in your mind's eye, think about what the possible ways there are to divide into 6 and 21. They are a 3. Let's look at the variables. We have x squared and x. You can definitely divide out or take out an x. So there's your answer for number 29. That's your greatest common factor, 3x. Now, if you had trouble with that, you can always break down the 6 into its factors. 6 is 2 times 3, x is x, and 21 is 3 times 7, x. And if I circle the common factors, you'll see that I come back to my GCF that I got mentally up there, okay? So that's one way of looking at it. Let's try number 30. We have BC squared and B cubed C. I can definitely take out a B, a single B. There's only one of them in both terms. And there's the lowest number I can have is C in both of them for number 30. And there it is, ladies and gentlemen. The greatest common factor is BC. Number 31. With 3 terms we have to deal with here, 14, 84, and 21. I'm going to break those down. 2 times 7 right there. What is this? 2 times, that's 42. 2 times 3 times 7. And the last one is 3 times 7. I kind of did the middle one in my head. Wow. Yeah, that works. And we'll deal with the variables in a second. We have a 2. Oh, we don't have a 2. My bad. Misspoke there. The only thing in common are the 7s. So that's the coefficient that you can pull out. And let's see, does every term have an x? Yep. The lowest x is 1. And does everyone have a y? Yes. The lowest y is squared. So I can pull out y squared from all 3 terms there. Yay. There's my GCF for number 31. 32. I'm going to go ahead and break down the 24. Let's see, there we go. And the 18. There we go. Circle common factors. Oh, it's 2 times 3, which is 6. Very good. Any variables? None. So 32, there's only 6 as my GCF. All right, 34 through 36 will do for this section, and we'll move on to the next section. Here we will take out a GCF like we did with 29 through 32, but we're going to continue and actually divide into the polynomial with that GCF, okay? So I'm looking at 15 and 42. I'm thinking of, let me zoom in a little more so you can see it better. I'm thinking of 3, 5, and right here, what's going on here? 2, 3, 7, and I can definitely take out a 3, and I can take out an x. When I say take out, I mean divide, right? So in my mind's eye, I'm going to divide 15x to the 3rd, divide by the GCF 3x, and that will give me 5x squared minus, in this case, whatever's left over, 14, and that's it. That's your answer. Not too bad, right? That's your answer right there. Great, 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 great. Number 34. Ooh, we have a trinomial. Let's break those coefficients into factors. Oh, there's my 42 again. Very cool. And I have an 18 here on the end. Definitely have a 3 in common and a 2 in common, which means my GCF involves a 6. Any variables? Let's see. Y. We have Y. Very good. That leaves me with, when I divide 6y to the 5th, my original, divided by my GCF 6y, that gives me y to the 4th. Very good. Middle term, negative 42y to the 3rd, divided by 6y is minus 7y squared. Very good. And then last term, 18y divided by 6y is plus 3. And there it is. Not too bad, right? Not too bad, not too bad. Moving on to number 35, same process, just more of the same stuff, just breaking things down. 12 is 2 times 3 times 2. Yep. 18, oh, I saw that earlier, 2 times 3 times 3. And 36 is 2 times 3 times 2 times 3. A lot of 2's and 3's everywhere. So we have a 2 and a 3. And that's it. Nothing else is in common. That's my GCF 6. Any variables here? Let's take a look here. A's, yeah, we have a single A, very nice. And when I divide by 6a, my GCF, I'll get, in this case, 2a squared. Notice the numbers that I'm not circled are what's left over, meaning the quotient. The middle term is 3a, and the last term is 2 times 3 is minus 6. There it is. Hey. All right, number 36, 49, 77, 14, 72, and 35, 75. So it's obvious that the number that's common is 7. Let's take out a 7. Great. And any A's? Oh yeah, we have an A everywhere and a single B everywhere. So when I divide by 7AB, I'll be get 15. Oh, 49 divided by 7 is 7. Take out an A and a B from there. That leaves me with B to the 4th. I'm sorry, A to the 4th. I misspoke there. B squared, yeah. Minus 2AB. And 35 divided by 7 is 5. And there it is. Not bad. I am skipping 37, 38. Any questions on 7-4, our first section? All right, let's jump to some actual factoring quadratics, also known as trinomials. Let's jump to 7.5. Here, we're going to do a form of guessing and checking. Because A is 1. The leading coefficient is 1. That makes factoring this quadratic easy. That's called a quadratic. Okay. Zoom out a little bit. So what we're going to do, you can always look at this table here. We're going to imagine what we're trying to do here is we're trying to factor it to this. A binomial times a binomial. Think about FOIL briefly here. When you FOIL a binomial times a binomial, the inner and the outer terms will usually combine together, okay? That's the middle term bx. Bx is where the inner and the outer terms add up to get to those, the middle value there. So here, O plus I, okay? The last term is C, will help us add to get B. That's the key here. So look at number 39 here. 39 has negative 18 as my C value. Let's write this up here. X squared plus bx plus c. My C value is very critical. Whoops. Right here. We need to list all the factors of C and then add the factors together because that's my inner and outer terms. Because we're trying to shoot for B, our B term. Yeah? And the B is made of the outer and inner terms. That's why we're adding them together. That's why. It's sum. Yeah? So right now we have a table. They're just randomly having us to throw some numbers in. What times what equals negative 18? This is mental math. So I'll put in a couple of things that pop in my head. How about negative 1 and 18, right? Negative 1 times 18 is negative 18. When you add negative 1 to 18 together, you'll get 17. That is not my middle term. My middle term that I'm trying to shoot for is 7x. That's what I'm shooting for. Okay. Another possible pairs is positive 1 and negative 18. Add those together, you'll get negative 17. Not my middle term, is there? But there's one pair of numbers, when you multiply together and add together, it'll give you positive 7, okay? In this case, it's going to be 9 and 2 somehow. So I'm just trying to walk you through writing the numbers down first and realizing one of them has to be negative, one of them has to be positive. So I want to slap on a negative to the 2, which will give me a positive 7 when I add those together. Ding, 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 there it is. If I add this together, they'll give me a positive 7. And there's my table filled out. Very good. All right. I'm going to need a little space here for 40 through 43, if you don't mind. A lot of this stuff can be done in your head. So I'm going to do number 40 first, right here. We're trying to factor x squared plus 12x plus 32. We're working backwards of the first half of chapter 7, okay? There's only one way when it comes to FOIL to get x squared. There's only one way. That is x times x. There's only one way. How many ways are there to get 32, though? I'm going to think all the possible. Now, we're trying to get the sum of those two factors when added together will give me my 12x. This is the b value. That's what I'm trying to shoot for. I'm going to list all the possible ways of 32. They are 132, 2, 16, 4, 8. That's it. Those are all the, oh, look. 1 plus 32, nope. 2 plus 16, nope. Oh, 4 plus 8 is 12. Ding, 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 ding. There it is. That goes into right here and right there. When you FOIL, when you add the inner and outer terms, you will get 12x. And that's how you do number 40. 41 is next. Let's do that one. We're trying to factor x squared plus 3x minus 28. Now the last one was positive, positive, and my answers were positive, positive, but this one's kind of interesting. One of them is going to be positive, one of them is going to be negative. I'm trying to shoot for, in this case, 3x, based off of the sum of the products, some of the factors of negative 28. So, you know, you can do this in your head. Negative 1, 28, no, negative 2, 14, getting close. Negative 4, 7, what? There it is. Negative 4 plus 7 is 3. There it is. Put that in there. X minus 4, x plus 7. Ding, 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 ding. Number 41 is done. 42 is next. This guessing and checking is not too bad. You can write it down if you can't do that mentally in your head. That's okay. Ooh, negative 42. My middle term is negative 13. Be careful there. All right, here we go. So there's only one where we get x squared, right? XX. Negative 48, there's a lot of possibilities. Negative 148, negative 224, getting there. Negative 316. Oh, look how close that is. What if I made it positive 3, negative 16? Ding, 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 ding. There's my pair. Just by switching the sign, it matches the negative 13 from my middle term right there. There we go. Not too bad. 43. Last one for this section. Here we go. X squared plus 18x. Ooh, xy. We got an extra variable, folks. Pretend the y's aren't there, okay? That's an easy way of looking at this. There's only one way to get x squared, of course. How many ways are to get 45? Let's take a look here. Let's do this. Well, let's put down here. 145, 2, 315. What? I almost went to 5, 9, but 315 work. Yes. Something that we could kind of forget sometimes. Try all the possible numbers to factor into it. There's your answer. Oh, wait. Did I ignore the y for a moment? So what you want to do is put the y back in. There's that one. There's that one. Down is that. Yes. Any questions about 7.5? Let's jump to 7.6. The heart of the chapter. This is one of the methods of this time. It's just like 7.5, but a is not 1. It's some other number, which makes this process a lot harder. What I'm going to do for this section is teach you guys the AC box hybrid method, okay? There are 5 steps. Please jot this down. Do it a few times, you'll get used to it, and then it'll be much easier. Step 1. Take your quadratic, take the first term, put it in the first box. Last term in the last box. Middle term, put it in the lower left-hand outside corner. Okay, that's step 1. Step 2, multiply the first and last terms. We refer to this as A times C. Step 3, find the sum of factors AC to match the middle term B. Find the sum of factors of AC equal to the middle term. B. Step 4, place those factors in the box. Step 5, find the GCF of each row and column. And that's how you factor complex quadratics. Give you a moment to write that down. And we're going to try some of these. I am going to skip 45 and 46 though. I don't like those, not necessary. I will jump to number 47. Any questions so far? Okay. So I'm going to give myself plenty of room here In fact, I'm going to borrow some of room for number 45 area. Let's do 47 first. Good luck, everybody. Here we go. 47. Draw a box. First term, first box. Last term, last box. Middle term, lower left-hand corner. Step 2, multiply a times c. In this case, 3 times 8 is 24, x squared. Step 3, find the sum of factors of AC. So let's do that. Break that down. To equal the middle term. So 24, I have 1 times 24. I'm going to give myself a little more room here. Sorry. 1 times 24, 2 times 12, 3 times 8, 4 times 6. Oh, there it is. 4 times 6 is 24. 4 plus 6 is 10. Ding, 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 ding. We have a winner. Put those in the box. Doesn't matter where you put them, though. Step 5. Find the greatest common factor of each row and column. Let's do that. First row, let's see, 3 and 4 can't take out a number. However, I can take out an x. Second row, take out a what from 6 and 8? Or 2. Nice. First column. So those are the rows. First column. 3 and 6, I can take out a 3 and an x. Nice. Last column, I can take out a 4. Ding, 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 ding. There's my answer, ladies and gentlemen, for number 47. It is 3x plus 4 times x plus 2 is the answer for number 47. Yay. 48's next. Yeah, we're going to get through all these. Draw your box. First term, first box. Last term, last box. Middle term, lower left-hand corner, outside corner. All right. This multiply step 2. Multiply those together. Negative 40x squared. You can do like mental math here. This is kind of an interesting problem. Number 48 has a minus sign, which means one of the factors is negative, one of them is positive. So think of all the possible ways of getting negative 40, like negative 140. When added together will give me negative 3x. That's the target, okay? Nope, not there. Negative 220. Getting close. Negative 410. Very close. Negative 5, 8. Ooh, just switched a sign. Negative 8, 5. There it is. Ding, 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 ding. That works. Negative 8x. Doesn't matter where you put it. Okay. And 5x. I just had a momentary pen malfunction. Step 5, GCF each row and column. First row, 4 and negative 8. I can take out a 4x. Second row, I can have a 5. Okay, take out a 5. Yay. First column, you can't take out a coefficient. However, you can take out an x. Last column, be careful here. The first term starts with a negative, which means I have to take out a negative something. Negative 2. And there it is, ladies and gentlemen. My answer. 4x plus 5 times x minus 2. Yay. All right, very good. 49's next. Could have to need some room. Give myself a little more room. Oh, here we go. Let me do it right over here. 49, draw a box. First term, first box. Last term, last box. Watch out for those negatives. Carry those as well. Middle term, lower left-hand outside corner. Multiply the diagonal there. Negative 30x squared. What times what equals negative 30? When added together will give me positive 7. Don't be a hero. List them. Negative 130, negative 215, negative 3. Did I just get lucky? 10. There it is. Yay. Ding, 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 ding. Put those two terms in the box with an X. Sometimes I forget the X, sorry. Last term, GCF each row and column. First row, I can't take out a number, however, I can take out an X. Second row, I can take out a number, a 2 would work. First column, let's see, a 5X. And the last column, the first term starts with a negative, I have to take out a negative, and you can take out a -3, very good. That's the answer, yeah. You can always check by foiling those answers if you want to. You don't trust yourself on me. Here we go, 5x minus 3 times x plus 2. Woo! Halfway to this the section, yay. Let's do number 50, sorry. Number 50, draw the box. Hope I don't run out of room here. First term, first box. Last term, last box. Middle term, lower left-hand outside corner. Multiply the diagonals up 2. Ooh, I have 36x squared. Let's think of all the possible ways of getting that. We have 136, 218, 312, 4. Oh, there it is. 4, 9. 4 plus 9 is 13. 4 times 9 is 36. Those go into the box. GCF each row and column. First row, I have a 2x. Yeah, that looks right. Last column, I have a +3 that can go into those numbers. First column, 6 and 9, I can take out a 3x. Last column, 4 and 6 is a 2. There it is, 3x minus 2 and 2x plus 3. Did I say minus 2? I meant to say plus 2. Yay, there it is. That should work. Whew. All right, number 51 is next. Let's do that. 51, here we go. 51, draw a box. First term, first box. Last term, last box. Middle term, lower left-hand outside corner. Let's multiply the diagonal there, the AC. Those are the terms from the quadratic itself. I get -40x squared. Oh no, one of them has to be negative, one of them has to be positive. -140, I'm trying to reach 3x by the way. -220, nope. -3 will not go in there, 4 and 10. Close. -5, 8. There it is, yay. -5, 8 goes into the box. And now you want to do GCF each row and column. First row, 10 and 5. Oh, you can take out a 5x. That's easy. Second row, 8 and 4. How about a 4? That works. And how about the first column? We're done with the rows. What can go into 10 and 8? Let's see. 1, 2, 3, 4, 5. 4 works. X. And the last column, nothing is common except -1. Okay, take care of that. So number 40, I'm sorry. Number 51, the answer is 5x plus 4 times 4x plus, oh, sorry, minus 1. All right, last problem in the section, here we go. Oh yeah, I got room right here. 52. Ooh, those are some crazy numbers there. Draw a box. First term, first box. Last term, last box. Middle term, lower outside corner. Great. Multiply the diagonal together. I got 72x squared. That's a menacing number. Let's break that down. We're trying to get 22, by the way. 172, 236. There's 3 go into there. 24 times. It does. 4 goes into there too. 1, 4, 3, 2, 18. Oh, there it is. Yay. Got lucky there. Great. Put that in the box. And GCF each row and column. First row, let's see, 12 and 4. Oh, yeah, I can take out a 4. Take out an X. Yay. Second row, I can take out a 2, 3, oh, 6. Very good. First column, I can take out another 6, x squared. Oh, no, just a 6x. And then the last column, I'm going to have to do plus 2. Yep, there it is. Final answer for number 52 is, oh, we have a problem, folks. I see that 4x. That can be broken down further, right? You can take out a 2 from there. When you take out a 2, you'll be given 2x plus 3. Interesting. So here in my answer column, I totally forgot about that. 2 times 2x plus 3 times the other mom, 6x. Oh, you're kidding me, right? What else can I take out? 2, 6, 22, 4x. I'm just double checking everything, folks. Sorry about that. 4, 6, 6, 12. Ooh. Oh, that's weird. Did I jot it down wrong? This is awkward. 72. 22, 72, yeah, that looks 4x. 18, 6, 4, 6x, 2. Oh my gosh. This is fascinating. All right. For some reason, this 52 is not coming out. We're going to skip that. Any questions about this section? Come back to that in class, trust me. Let's jump to the last section. I'm sure you guys are anxious to get to the last section. 7-7 are special factor cases. There are 3 of them for us to look for. Perfect square trinomials is a special case. PST, I call them. And when you square a positive or square a negative, you'll get these patterns right here. You can use them if you want to. If you don't want to use them, that's up to you guys. The one I do want you to memorize definitely is called the difference of 2 squares. And this is what you get when you multiply an a plus b times an a minus b. Notice that the inner and the outer terms do cancel each other out. This is what happens when you multiply these things called conjugates. There's an example of that right here. You can look through when you get a chance. That would be great. Let's jump to number 57. I'm going to do 6 problems here. Okay, we're looking for perfect square trinomials, and we're looking for difference of perfect squares. As patterns. Starting with number 57. Ooh, it's a trinomial, so it can't be a binomial, meaning it can't be difference of squares. How do we check it, right? You want to square root the first term, nice, square root the second term, and double it. So using my work up here to check that, the square root of x is x, the square root of 25 is 5, then I'm going to double it. When that happens, I get 10x. Yay, that proves that this is a PST. 10x is the middle term. Ding, 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 ding. Which means my answer when I factor that thing is x5, positive, positive, and you're done. You can rewrite it as x plus 5 squared if you want to. Doesn't matter. Either one of those are correct. All right, number 58's next. Ooh, it's a binomial. Let's check to see if it's a difference of squares. There's a minus sign. Great. Are those ends square rootable? Oh, they are. Those are perfect square. So this is a difference of squares, ladies and gentlemen. Number 58. So 58. So square root of x is square root is x. Square root of 121 is 11. So this is a situation where we have a minus plus situation, okay? And there's your final answer, yay. Number 59. Let me know if you have any questions, of course. X minus 11, x plus 11 for number 58, 59. Hey, we're doing great on time right now. Woohoo! We have a trinomial. Let's check to see if it follows the pattern. Square root the first and last terms. I have x and 9, and I'm going to have to double it. When I do that, I get, oh, 18x. Yay, it matches. This is a PST. Very good. So I have x, 9, x, 9. I got to be careful here. The middle term is negative 18, which means both of these are both negative. There's your answer. Makes sense. A negative times a negative is a positive 81. A negative plus a negative is negative 18. So that gives me my answer for number 59. That is, if I shrink it, x minus 9 squared. Ooh, looks like we have another binomial coming up with number 60. Any questions on 59? Number 60. We have to check, oh, we do have a minus sign. Is 9x squared square rootable? Yes, that is 3x. Interesting. Square root of 49y squared is definitely a perfect square. In that case, we have 7y. Now, this is a difference of perfect squares. This is going to be a minus plus. And that's it. That's how easy those are. Love them. So there's your answer for number 60. Yay. All right. Let me know if you have any questions. 61. Ooh, I noticed a 3, 18, and a 27. I can't square root the 27 over 3. However, can I take out a 3 as a monomial GCF and see what happens? Let's do that. When I do that, I'm left with x squared plus 6x plus, ooh, definitely looks familiar. X squared is square rootable, 9 is square rootable. So number 61, I took out a 3, great. Then I took out an x when I square rooted the x squared, and a 9, which square root of 9 is 3. When I double it, I will get the 6x. So this is a PST, ding, 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 ding. That was the middle term right there, 6x. Yay. Let's rewrite this whole thing. The 3 from earlier, these are all positives. And there's your answer. Yay. Not too bad. You can put an or here if you want to. To make it look nicer, this is my final answer when I group the x plus 3's together. Yay. 62 looks gigantic. Can I take out a 4? Yeah, I can take out a 4. When I take out a 4, I'm left with x squared minus, let's see, 1, 14, carry that, plus 4, 16. Oh, there it is. It's PST maybe? Let's check the math here. Square root of x squared is x. Great. Square root of 49 is 7. Nice. And we double it. And that will give me my 14x. Yay. The middle term. All right, let's piece this all together and we're done. Whew. Under 40 minutes, that's not too bad. Take the 4 from earlier, perfect square, x7, x7. This is both minus minus, yay. And if you group it all together, you'll get 4 times x minus 7 squared. Thank you very much. That's 40 minutes. Have a good day. Bye-bye.